This is question 44 on chemistry from the 2020 IMAT. So we're asked which one of these 5 substances has the weakest overall intermolecular forces out of water, methane, hydrogen fluoride, ammonia, and carbon dioxide. So firstly, let's think about the different types of intermolecular forces that we know. So the weakest one is van der Waals forces. This is something that's experienced by all molecules, and it just depends on interactions between polarized electron clouds around the molecule. What is the next strongest? Well, this is dipole-dipole interactions, where if a molecule has a permanent dipole, then these interact favorably to give intermolecular forces that are slightly stronger. And then what is the strongest? So this is hydrogen bonding, where if we have hydrogen bonded to a very electronegative atom, that is nitrogen, oxygen, or fluorine, then there will be a very strong interaction between the hydrogen and the lone pair of this electronegative atom. So let's bear this in mind and think about the strongest intermolecular force present in each of these 5 substances. So firstly, what about water? Well, what does water look like? We know it has this bent structure where oxygen has 2 lone pairs and is bonded to 2 hydrogens. What is the strongest intermolecular force that oxygen experiences? So as we said, if hydrogen is bonded to a very electronegative atom, then there is a strong bonding interaction between another hydrogen from another molecule and this lone pair. So we know that water has hydrogen bonds, which are very strong, and that's the reason water is a liquid at room temperature. So we know it's probably not going to be water, so let's carry on looking at our different substances. So what about methane? Well, what does methane look like? We know it has this tetrahedral structure. And so what is the strongest type of intermolecular force present? Well, it doesn't have a very electronegative atom, so we won't have hydrogen bonding. What about dipole-dipole interactions? Well, although there is a slight dipole across each of these individual CH bonds, they all cancel out because this has a totally symmetrical tetrahedral structure. So there's no overall dipole in this molecule. And so that means the only force we have present is these weak van der Waals forces. So this looks like methane might be a good contender. So let's carry on look through each of these substances. So what about hydrogen fluoride? Well, this has a simple structure of just hydrogen connected to 1 fluorine. What do we think the strongest force present in a sample of this would be? So again, fluorine is one of the very electronegative atoms, and so we'd see hydrogen bonding interactions in this molecule. So we know, so far, methane looks like it might have the weakest intermolecular forces. Let's just look at our last 2. What about ammonia? So ammonia has this trigonal prismatic structure with a lone pair on the top of nitrogen. What forces do we think are present here? Well, again, we have a very electronegative atom connected to hydrogen, and so we're going to have hydrogen bonds to adjacent molecules. So finally, we get to carbon dioxide. What do we think about this one? So carbon dioxide has this linear structure where carbon forms a double bond to oxygen on opposite sides with no lone pairs on carbon, that is. So what sort of intermolecular forces do we think are present? Well, both of these bonds are very polarized towards oxygen, but because of the symmetry of this molecule, both of these dipoles will cancel out, and so the molecule as a whole has no permanent dipole. So that means the only force present will be van der Waals forces. So what do we think will have the weakest intermolecular forces overall? So it's going to be a toss-up between methane and carbon dioxide, but which one do we think it is? Well, the strength of van der Waals forces depends on the overall number of electrons in the molecule, because that means a molecule with more electrons will have a bigger electron cloud, which is more easy to distort and cause favourable interactions with neighbouring molecules. So which of these molecules has more electrons? Well, let's think about carbon plus 4 hydrogens versus carbon plus 2 oxygens. Now, we know hydrogen has only 1 electron, oxygen, in fact, has 8 electrons. And so we know the compound with more electrons is carbon dioxide, and so this will have stronger van der Waals forces than methane. And so we've narrowed it down to 1. We know that the substance with the weakest intermolecular forces will be methane. And so this is our final answer, which corresponds to B.